Let us discuss density, beginning with this problem right here. What is the density of silicon if 50.6 grams occupies 21.72 milliliters? Well, density, we represent density with the Greek letter rho, which looks like that. And density is an object's mass divided by its volume. And I don't like the way that pen is writing. So if I know an object's mass and its volume, I can calculate its density. Now, density can be measured in any number of units. It can be measured in grams per milliliter. It can be measured in kilograms per liter. It can be measured in pounds per cubic feet. As long as you have some measurement of mass divided by some measurement of volume, that will give us density. But typically, density is measured in grams per milliliter. And that's what we use for this right here. So by definition, density, rho, is equal to number of grams you have divided by the milliliters. So in this case, we have 50.6 grams divided by 21.72 milliliters. So I'll just pull my calculator in here, and we'll say 50.6 and 21.72 and divide that. That comes out to 2.329. Now I should have three significant figures. And 2.3296, well, I'm only going to go back as far as 2.32, but the 9 will make that last 2 a 3. So 2.33, and my units are grams per milliliter. So there you go. The density of silicon is 2.33 grams per milliliter. And there you go. Which means if I had a sample of something and I found it to be 2.33 grams per milliliter, it's a pretty fair bet that it's silicon. All right, very good. All right, that wasn't too difficult. Let's try another one. What is the mass of a rectangular piece of copper, 24.4 centimeters, 11.4 centimeters, by 7.9 centimeters? The density of copper is 8.92 grams per cubic centimeter. All right. Well, we have a rectangular piece of copper. So let's say that it looks something like that. There we go. And we are told that it has measurements of, this is not going to be to scale, of course. Let's go 11.4 centimeters. 24.4 centimeters, and 7.9 centimeters. Now the volume of a rectangular solid is the length times the width times the height. So to find the volume of this rectangular piece of copper, I will just multiply 11.4 centimeters times 24.4 centimeters times 7.9 centimeters. All right, so let's do that. Let's say 11.4. Say 24.4 times and 7.9 times. All right, this comes out to 2,197.464 cubic centimeters. Remember to cube your units too, because we're not only multiplying the numbers, we're multiplying the units. So centimeters times centimeters times centimeters is centimeters cubed, or centimeters to the third power. Okay? Now this number here does not correspond to my significant figures, but I'm not going to worry about that. I will worry about that in my final result, because what I'm trying to find is the mass. Okay? Now recall that density, rho, is equal to mass divided by volume. Now, if I solve this equation for mass, that tells me that mass should equal volume times density, or volume times rho. That's just using a little algebra there, multiply both sides by the volume. So if mass equals volume times rho, then the mass, which is what I'm trying to find, should be equal to our volume, which we now know is 2197.464, and that is cubic centimeters, times the density, which is 8.92 grams per cubic centimeter. Now, when we calculate this, note that the cubic centimeters here are in the numerator, here it's in the denominator. They will cancel out, and we're left with grams, which is what we expect since we're finding mass. So now, finally, the mass will be equal to this times 8.92. I still have that in my calculator, 8.92 times. Now, that comes to 19601.37 blah blah blah. However, I'm restricted to at most 2 sig figs. So the final answer to this will be 19, but the 6 will make that so 20,000, and my units are grams. And there we go. The density, the mass of that rectangular piece of copper would be 20,000 grams. All right, very good. Very good. See, once I know density is mass over volume, I can use that same formula to calculate not only the density if I know the mass and volume, I can calculate the mass if I know the density and volume, or I can calculate the volume if I know the density and the mass. Case in point, what is the density? Oh, vinegar has a density of 1.0056 grams per cubic centimeter. What is the mass of 3 liters of vinegar? All righty, well. Now you might notice they're asking for an answer in liters, but they're giving the density in grams per cubic centimeter. Well, recall that 1 cubic centimeter is precisely equal to 1 milliliter. So you could say that density has, vinegar has a density of 1.0056 grams per milliliter. I certainly could. And that's what we will do. Now recall that rho, or density, equals mass over volume. And I'm trying to find out what the mass of 3 liters of vinegar is. So mass, as we just saw, is equal to rho times volume. All right. Well, I know my density is 1.0056 grams per milliliter, and I want to multiply that by the volume, which we're given is 3 liters, but hang on, I can't multiply liters times milliliters. They either both have to be in milliliters or both have to be in liters, and it's much easier to convert 3 liters, well, not easier, but it's at this stage, it's going to be easier for us to convert 3 liters into milliliters, because you will recall that 1 liter is equal to 1,000 milliliters. So 3 liters of vinegar would be 3,000 milliliters of vinegar. And again, because milliliters is in the denominator here and the numerator there, milliliters cancels out. We're left with gram. So after finding mass, that's what we'd expect. All right, so let's try this. 1.0056 and 3,000. And we will times that. Pow! That comes out to 3,016.8 grams. But we only have one segment figure because this was 3 liters, and it doesn't say exactly 3 liters or 3.0 liters, so it's just one sig fig. So our final answer will just be 3,000 grams. And there you go. Okay. And finally, let's look at this one right here. A container has a mass of 73.91 grams when empty and 91.44 grams when filled with water. You don't say. The density of water is 1.0000 grams per cubic centimeter. So to 4 decimal places, they're just saying that 1 gram is equal to 1 milliliter or 1 cubic centimeter. That's really handy. Yes. Calculate the volume of the container. And when filled with an unknown liquid, the container has a mass of 88.42 grams. Calculate the density of the unknown liquid. Well, let's start with A here. The volume of the container. Well, I know that the container has a mass of 73.91 grams when empty and 91.44 grams when filled with water. So that means if I take 91.44 grams, which represents the container plus the water, and I subtract 73.91 grams, which just represents the container, that the result should be just the mass in grams of the water. So 91.44, 73.91 minus, that is 17.53 grams. And that is water, or H2O. So that is the mass of my water. Now, note that the density of water is 1,000 grams per cubic centimeter. So, since density equals mass over volume, then if I do some math, I'm going to multiply both sides by volume and then divide by rho. Then I could also claim that volume is equal to mass divided by density. There you go, mass over density. Volume is mass over density. Now, we look here, we see we have the mass of water, but because the density of water is exactly 1 gram per cubic centimeter, then this number also represents the volume of that water. And since this is the amount of water that was in my container, then I know the volume of the container must be 17.53 milliliters or cubic centimeters. Yeah, whichever one to use. We can just keep using cubic centimeters. So once again, we know by subtracting the amount when the container was filled with water from the mass of the empty container, that what we have is the mass of the water, but the density of water is just 1. That means this value also is the volume of the water, since 1 gram equals 1 cubic centimeter. So I'm trying to find the, so the volume, I know that. I don't know why I bothered doing that. Okay. So when filled with an unknown liquid, the container has a mass of 88.42. So density will be our 88.42 grams, some unknown liquid. I will call it liquid X. And I know that the volume of that container, because of this, must be 17.53 grams of, trying to say, grams, not grams, cubic centimeters. So the liquid has a mass of 88.42, and this volume, since it's in that container, must be 17.53 cubic centimeters. So I do the math. 88.42 enter. 17.53 divide. That equals 5 point. How many sig figs should I have? I should have 4. So 5.04, that's 39. So I will round that up to a 4. So 5.044 grams per cubic centimeter. Okay. All right, let's run through that again real quick. This was answer B. So answer A, I know that the container weighed 73.91 grams when empty, and when filled with water, it contained 91.44 grams. So if I subtract those two, that will just give me the mass of the water. But the mass of the water, the density of the water is 1. So the mass and the volume are the same. So 17.53 grams of water is equivalent to 17.53 milliliters of water, and milliliters are cubic centimeters, which means that the the volume of my container must be 17.53 milliliters or cubic centimeters. And since rho equals mass over volume, then rho equals the mass of our unknown liquid, 88.42, divided by the now known volume of the container, which is 17.53 cubic centimeters or milliliters. And that comes out to 5.044 grams per cubic centimeter. Yes, it does. Alert, alert, alert. I made a mistake right here. As I noted, this should have at most 2 significant figures. And their answer is 19601, so we should back up to 19. But the 6 should make that a 0. But the answer as I wrote it only has 1 significant figure in it. So the answer really should be, where's my pen? 2.0 times 10 to the 4 grams. That is a better answer because it accounts for 2 significant figures. Okay, whew, crisis averted. Well, there you go. I hope that helped.